Section 3.5 of your textbook introduces the topic of slope. The slope of a line is a way of measuring how steep the line is. And slope is defined as the rate at which y is changing with respect to x. To find the slope of a line from its graph, we can simply identify 2 points on the line and write the slope as the ratio of rise over run, where rise is the change along the y-axis and run is the change along the x-axis. Let's look at some examples. First, for the red line, we can see that it passes through the point 1, 1, and then also through the point 4, 3. Therefore, we can write the slope of this red line, noting that there is a change from 1 to 3 on the y-axis, which is a distance of 2. So that's the rise. And then there's a change from 1 to 4 along the x-axis. That's a distance of 3. That's our run. Therefore, the slope of this red line is 2/3. What about the green line? Well, we can pick any 2 points we want on the green line to find the slope. Perhaps we can start with the point -2, 3, and then we can look at, again, another point, 1, -3. In this case, we see as we move from that first point to the second point, we actually have to move down along the y-axis, down a distance of 6. So in this case, we define the rise, since it's actually a fall rather than a rise, we define it using a negative number. So the rise is -6. The run is still to the right in the positive direction for x. That's a distance of 3. So the slope of our line is -6 over 3, which simplifies to the number -2. The slope of the green line is -2. Let's do a few more examples. Let's find the slope of the blue line. We can see it passes through the origin. It also passes through the point 1, 3. That will be a rise of 3 and a run of 1. So 3 over 1 simplifies to a value of 3 for the slope of the blue line. How about the red line? Well, we can see that the red line passes through the point -2, 2, and it also passes through the point 1, -2. That's a rise of -4 and a run of 3. So the slope of the red line is -4/3. The green line is a horizontal line. In this case, we could pick any 2 points along this horizontal line and notice that they have the same y value. In other words, there is no rise to this line as we move from one point to another. The rise is 0. The run, well, in the case of the points we picked, is 2, but it actually doesn't matter because 0 divided by any number, 2 or 1 or anything, is still 0. The slope of this green line is 0, and in fact the slope of any horizontal line is 0. What about the yellow line? This is a vertical line. So there is a change along the y-axis. If we pick 2 points, we can see, in this case, a rise of 2. What about the run? That would be the change along the x-axis. To the left or to the right, this line is not moving to the left or right at all, so the run is 0. 2 divided by 0, remember, is not 0. This is undefined. The slope of any vertical line is always undefined because we are always dividing by 0. Summarizing these results, we can draw some quick conclusions. Note that for the blue line, the line is moving up as we move from the left to the right along the graph, and the answer to the slope is positive. The red line, on the other hand, is moving downhill as we move from the left to the right on the graph, and its slope is negative. This is true in general. As we look from the left to the right along a graph, if we see the line moving uphill from left to right, we know there's a positive slope. And if we see the line moving downhill from left to right, we know there's a negative slope. We've also seen that the slope of a horizontal line, which moves neither up nor down, is 0. And we've seen that the slope of a vertical line, which moves both up and down, is undefined. It's actually possible to calculate the slope without access to a graph. We can find the slope of a line just from knowing any 2 points that the line passes through. We do that using the formula shown on this slide. We will find the difference of the y-coordinates, make that the numerator of our slope. We'll find the difference of the x-coordinates and make that the denominator of our slope. In the formula, the subscripts 1 and 2, little numbers to the right and below the x's and y's, are simply indicating the x and y coordinates of each point. Let's look at some examples. We'll find the slope of the line through each pair of points. In the first case, we have an x in our first point of 0 and a y in our first point of 5. And then the x of our second point is 4 and the y of our second point is 7. Therefore, using our formula for slope, we take y sub 2, or 7, minus y sub 1, which is 5, over x sub 2, which is 4, minus x sub 1, which is 0. Since 7 minus 5 is 2 and 4 minus 0 is 4, we have the fraction 2/4, which simplifies to 1/2. The slope of the line through these 2 points is 1/2. Let's look at a second example. Once again, we can see the x-coordinate and y-coordinate of our first point, and then over here the x-coordinate and y-coordinate of our second point. And to calculate the slope, we simply substitute those values into the formula. Y sub 2 is 2 minus y sub 1, which is negative 4. X sub 2 is negative 3 minus x sub 1, which is 1. Note that 2 minus negative 4 is the same thing as 2 plus 4, so we have 6. In the denominator, we have negative 3 minus 1, and that would be negative 3 plus negative 1, which is negative 4, giving us a slope in simplest form of negative 3 over 2. Let's look at our third example. We have, again, 2 points with an x sub 1 and y sub 1 coordinates, and then x sub 2 and y sub 2 coordinates. In this case, y sub 2 and y sub 1 are both 5, x sub 2 is 3, and x sub 1 is negative 2. This results in a value of 0 for the numerator and 3 plus 2, or 5, for the denominator. But 0 divided by 5 is 0, so the slope of this line is 0, which means it must be a horizontal line. One final example. Once again, we'll take these coordinates and replace them in our formula. In this case, y sub 2 is 9, y sub 1 is 8, x sub 2 is 6, and x sub 1 is also 6. This leads to the fraction 1 over 0. 1 divided by 0, remember, is undefined. So that's the slope of our line. And since that slope is undefined, we know that this actually must be a vertical line that passes through these 2 points. In summary, in addition to calculating slope, we've learned that the slope of a horizontal line is 0, the slope of a vertical line is undefined, and a line having positive slope slants up from left to right, while a line having negative slope slants down from left to right. One final fact about slope that is useful to remember is that the larger the absolute value of the slope, the steeper the line. For instance, a line having a slope of 3 goes up more steeply, rises more quickly than a line having a slope of 2.